Hello, welcome to this second unit, that is the dynamics of fluids. Steady and unsteady flow, that is the types of flow, the uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotation and irrotational flow, one-dimensional, two-dimensional and three-dimensional flow. Steady flow and unsteady flow. The steady flow, it is defined as the type of flow in which the fluid characteristics like velocity, pressure and density etc. at a point do not changes with the time. That is a dou p by dou t x equals to 0, y equals to 0, z equals to 0. Then dou v by dou t x equals to 0, y equals to 0, z equals to 0. Then dou p by dou t dou rho by rho t, that is x equals to 0, y equals to 0, z equals to 0. Unsteady flow, this type of flow in which the velocity, pressure and density etc. at a point changes with the time, means it is not equals to the 0, that is dou p by dou t, dou v by dou t, dou rho by dou t. Then uniform and non-uniform flow. Uniform flow, it is defined as the type of flow in which the velocity at a given time does not changes with respect to the space. That is a dou v by dou s, that is a t is equals to constant equals to 0. Non-uniform flow, it is defined as the type of a flow in which the velocity at any given time does changes with respect to the space. That is a dou v by dou s, t is equals to constant is not equals to the 0. Laminar and turbulent flow. Laminar flow, it is defined as that type of flow in which the fluid particles moves along the well-defined path or streamline, and all the streamlines are straight and parallel. The Reynolds number is less than 2000, then the flow is known as laminar flow. Turbulent flow, in this is that type of flow in which the fluid particles moves in a zigzag way, and do, due to this the movement or eddies formation will be takes place, which responsible for the high energy loss. That is the Reynolds number more than 4000, then the flow is called as the turbulent flow. Compressible flow and incompressible flow. Compressible flow is that type of flow in which the density of fluid changes from point to point, or in other words, density is not constant of the fluid, that is rho is not constant, then it is called as a compressible flow. Incompressible flow, it is that type of flow in which the density of a fluid not changes from the point to point, or in other words, the density is constant for the fluid. That is liquids are generally taken as a incompressible and gases are taken as a compressible fluids. That is rho equals to constant. Rotational and irrotational. A rotational flow, it is that type of flow in which the fluid particles while flowing along a streamline and also rotate about their own axis. About their own axis. Then irrotational flow, it is that type of flow in which the fluid particles while flowing along a streamlines and do not rotate about their own axis. That is called as irrotational flow. That is one dimensional flow and two dimensional and three dimensional flow. One dimensional flow is that type of flow in which the flow parameters such as velocity is a function of time and on one space coordinates only, that is u is equals to f of x, that is v is equals to 0 and w equals to 0. P is the motion along the x-axis and v is equals to along y-axis and w equals to z-axis. Then two-dimensional flow is that type of flow in which the flow parameters such as velocity is a function of time and two rectangular coordinates, that is x and y, and f2 equals to x and y, w is equals to 0. That is a three-dimensional this type of flow in which the flow parameters such as velocity is a function of time and the three mutual perpendicular space coordinates, that is x, y and z. U is equals to f1 x, y, z, and v is equals to function of x, y, z, and w equals to function of x, y, z, that is rate of flow or rate of discharge. It is defined as the quantity of the fluid flowing per second through a section of a pipe or a channel, or it is for an incompressible fluid rate. The discharge is expressed as a volume of fluid flowing across the section per second, that is mathematically that is q is equals to a into v meter cube per second, and where a equals to cross sectional area in meter square and v is equals to average velocity of the fluid across the section in meters per second, and q equals to rate of discharge, that is meter cube per second. Then continuity equation, the equation based on the principle of conservation of mass is is called continuity equation. Thus, for a fluid flowing through a pipe at all the section of the pipe, the quantity of water flowing the quantity of water flowing per second is constant. That is v1 is equals to velocity of at cross section 1, rho 1 is equals to density of the fluid at section 1, and a1 is equals to cross section area of the pipe at section 1, that is, and v2 rho 2 and a2 are the corresponding values at the point 2, and they according to the laws of conservation of mass rate of flow at section 1 is equals to the mass rate flow at section 2, that is rho a1 v1 is equals to rho 2 v2 a2, that is the fluid is incompressible, therefore rho 1 is equals to rho 2, then you can call as a q is equals to a1 v1 is equals to a2 v2, that is. So next you can have the problems on the continuity equation. Here the problem given, that is the diameter of the pipe at a section 1 and 2 are 10 centimeter and 15 centimeter respectively. Find the discharge through the pipe if the velocity of water flowing through the pipe at section 1 is 5 meters per second, and determine also the velocity at section 2, that is given data are that is a d1 10 centimeter, d2 15 centimeter, and v1 is equals to 5 centimeter per second, and cross section area at section 1 equals to pi by 4 d square, that is. Pi by 4, then cross section area at the section 2, cross section area at the section 2 equals to pi by 4 d2 square, then cross section area at 1 equals to pi by 4 d1 square, that is, then rate of discharge equals to q1 a1 v1 is equals to a2 v2, or a v2 equals to 10 centimeter per second square, and the velocity of the flow equals to q divided by a2, that is a pipe AB, the branches in two pipes C and D as shown in figure. The pipe has a diameter as 0.45 meter at 0.3 meters, at B equals to 0.2 meter, and C and D equals D at C and D, that is 0.15 meter at D. Find the rate of find the discharge at A if the velocity of flow of water at A is 2 meters per second, and find out the velocities at A, B, and D if the velocity at C is 4 meters per second. Here the given data, that is dA is equals to 0.45 meter, and d2 dB is equals to 0.3 meters, and dC is equals to 0.2 meter, and dd equals to 0.15 meter, and v is equals to 2 meter. You can find out the cross section area, that is pi by 4 dA square dV square dC square and dd square, that is. So you can find, first you have to find out the rate of discharge through the pipe, that is qa is equals to pi by 4 dA into va square. So that is a 0.3 meter cube per second, and it will be branched out into the two, that is BC and BD, that is. So you can find out the rate of discharge at C. QC is equals to pi by 4 DC square into VC square. So that is 0.12 meter cube, and velocity at B is equals to VA into V divided by AB, that is. So you know the discharge through the A is QA is equals to QC plus QD, that is. So QC and QD equals to QA minus QC, that is 0.3 minus 0.12, 0.18 meter cube per second. Then discharge through the D, that is Q equals to AD into VD, that is velocity is 10.38, that is 10.38 meter cube meter per second, that is.